Recording in progress.
Buenos días, ahí ya estamos grabando.
Good morning. We are recording this session. On the screen, you have the instructions in order to choose the interpretation language. It can be English or Spanish.
¿Comienza, Sandín?
Do you want to start, Andine?
Sure, maybe just as a quick reminder, as Antonella said, please select the interpretation language, English or Spanish. And we are pleased to have you today for this webinar with my colleagues Fernando from FIIC and Afonso and Siga from FIEC. So maybe Fernando or Afonso, I will give you the floor for the openings.
Yes, maybe I can start. So thank you, Ondine, for making the invitation a couple of weeks ago to have a joint webinar between CICA and FIIC and FIEC on the topic of artificial intelligence, which is a topic that we are also starting to look at more closely. I will just say some very brief remarks on the work that FIEC has been doing, not just on AI, but more in general on digitalization. We started a working group in 2016, which was initially just focused on BIM, and then it was subsequently expanded to focus on the wider topics of digitalization. So it's now called the working group Construction 4.0. It's chaired by Giga Turk, who is has also connected to the meeting and has waved at you just now. And the aim is, in short, to follow relevant policy developments, mainly at EU level, inform also members and have discussions with members on a couple of priority issues, and give an opportunity for networking. So that we've noticed some participants, including external participants in the working groups, have taken the opportunity of the meetings to meet each other and then to communicate with each other, correspond outside the meetings and do some work together. And they can eventually report back on this work in our working groups. And just to make it short, some of the initiatives we've done have been on the relationship with software companies. So we've been doing webinars on that. We've also focused on cybersecurity, and we did a thematic workshop on that. And now we've also participated in some conferences with some of our members. And now, yes, we're starting to focus on the issue of AI and are looking into the working on a roadmap. And that's why we've joined CICA and FIIC also in this webinar.
Gracias. Bueno, bienvenidos a esta
Great.
actividad.
Thank you. Welcome to this opportunity. Welcome to this webinar of the CICA Working Group on investment on infrastructure. We meet every 2 months, so it is a pleasure to welcome you all. We have many attendees. We're happy about that, and hopefully this will be the beginning of very productive cooperation efforts. If you are not aware of this, CICA is the International Confederation of Builders Associations. Since 1972, we are gathering with federations, chambers, and building companies throughout the world. FIIC is the Inter-American Federation of the Construction Industry. It is part and is formed by Latin American countries building associations. It is part of the founding members of CICA, and both entities promote construction throughout the world. The acknowledgement by the community of construction's contribution to the quality of life and to competitiveness in other countries. And in particular, in our working group, we are focused on growing the investment on infrastructure because we understand that the infrastructure gap, the difference between the infrastructure that the users have and the users need, is very wide, and it's a growing gap. And in this particular case, we believe as well that it is very important to maintain the infrastructure that countries already have, because a lack of maintenance, which unfortunately is something common in many of our countries, degrades the asset and makes it increasingly difficult to provide an appropriate infrastructure service to the community and to our countries. FIIC and CICA work together. We have a very close and productive bond with our multilateral agencies. We thank AIGA from the World Bank for your participation and your support in these activities. And I would just like to begin today's meeting by introducing specific examples in which modern technologies have made it possible to have access in a more efficient way to the maintenance of infrastructure or construction assets throughout the world. So without further ado, let me move on to this session. We will have different presentations. The first one will be Aiga Stockenberga from the World Bank. Then we will hear Tomala Bus from the Altea company. And finally, in our last panel, we will hear Blanca Payas from Six Sense. Also, we will hear other presentations that Afonso will be talking about.
For FIEC, through the help of our member federations, we will have a presentation of Jean Ramirez from FFB and also group ISLODE, and then that will be followed by a presentation by Mate. I'm going to apologize for mispronouncing the name already. But I'll try my best. It's Matej Drześnik from GIC Granje. She is from Slovenia. So these are our two presenters. And now I give the floor back to Fernando.
All right, then let's begin with our first panel, which will be led by Aiga Stockenberga. She is a senior economist in the global transportation practice of the World Bank. She used to work in sustainable energy fields, commercial integration and logistics in the World Bank, the World Resources Institute, and the Ross Center for Sustainable Cities. She has published investigations on urban roads and infrastructure and planning for transport. Aiga has a master's degree in international energy policies from the Advanced Studies Institute of Johns Hopkins University and a PhD in environment and resources, specializes in the use of urban soil from other universities. Thank you for your participation, Aiga. We're looking forward to hearing from you.
Gracias, Fernando. Good morning, everybody.
Thank you.
So as Fernando introduced, I work at the World Bank. I'm a senior economist working primarily on Latin America and the Caribbean, but I also support the World Bank's knowledge products. For those of you who do not know, the World Bank is the largest multilateral development agency, but it is not just lending operations that the World Bank does, it's also a lot of knowledge production. So in that context, I wanted to talk about the use of satellite imagery and AI and broadly big data in the context of the broad range of work that the World Bank does. So just as a starting point, we know that the demand for data is high and growing, given the growing need for infrastructure in our client countries. And from the perspective of our analytical and operational needs, there's always, there's always a need for data at the country scale, and we tend to not have it even in our middle income and high middle income countries, such as, my region, which is, countries like Mexico, like Argentina, like Brazil. Even in those countries, we tend to lack kind of a data on the infrastructure condition and even the quantity of road networks that exist in these countries, especially when we're talking about smaller or rural roads that lead to agricultural production areas or isolated communities. We often lack that kind of understanding of what is the quantity and the quality of the road assets that our client countries are managing. And so just to give you a sense of, obviously the World Bank's primary business is lending, investment lending operations, and transport represents one of the largest lending sectors. We lend more to transportation than to health, education, social services combined. We need data. We need a good understanding of the quality and quantity of the networks to be able to inform those investment lending operations. It can be upstream, just when we're designing and sort of pre-identifying where is the investment going to happen. And then later on during the project preparation process, we need to be able to understand the condition of the assets in order to develop measuring indicators that we're going to use in our projects to measure progress over time. We also need consistent data across countries to be able to compare between them. So what we call benchmarking, obviously, this is very core to World Bank business. If you know, the Rural Access Index is kind of the primary indicator that the World Bank, but also other development agencies use. It's the only sustainable development goal that is linked to transport. And so for that, we again need consistent data across countries, and we tend never to have that even in our middle income client countries. And then the final application, which is more sort of what the analytical arms of the World Bank does, is research, statistical studies to be able to understand the relationship between infrastructure quality and outcomes that we actually care about, like schooling outcomes, health outcomes, poverty. And again, for those research purposes, we need consistent data across countries. So that is kind of there's a wide set of users of data within the World Bank that always require this data. And we've always been looking for a way to get that assessment of the infrastructure quality in an affordable way that can provide us with these insights. And so just to give you a sense a little bit in more detail, and I'll get into the examples of how we have actually leveraged satellite imagery and AI in some of these examples. So, like I said, in investment operations, there's a kind of a range of ways that we use, we need satellite imagery or something that can provide us with a comprehensive sense of the infrastructure condition. One is just the diagnostic of the quality of infrastructure to be able to prioritize road projects. The second way would be, condition is only one lens through which we can see where the priorities are. With the climate change, we often, and the Paris Agreement, we have a kind of a mandate within the World Bank to also to look at the climate resilience aspects of the road network. And so in that sense, it becomes important to layer different types of prioritization lenses, one on top of the other. So for example, the infrastructure condition, layering it on top of the climate vulnerability data. In some countries, we're bringing in road safety aspects. I'm going to mention some examples later. Or, for example, we want to combine the spatial assessment of the infrastructure condition with a spatial assessment of the criticality of these roads for different economic sectors. So basically, the point is that we serve as a technical advisor to the clients, to the governments of the countries, and so increasingly we need to come with this kind of technical knowledge and innovative data and solutions to be able to have an informed dialogue and prioritization of the investments that are not just based on political priorities. Another important point, and I think I'll mention this later as well, is that whenever we think of how could we leverage satellite imagery or other types of innovative data, we need to upfront think about how we're going to bring this into the country's own asset management systems. We cannot just do something in a World Bank office or hire a company to do something if it's not going to integrate with how the country itself is managing its road assets. And then the final point, as I mentioned, in investment lending operations, we need this kind of consistent data to be able to develop consistent indicators on road infrastructure condition across countries, but also within the project results framework to be able to monitor progress over time. So I'll just mention a couple of things. So one is, I mean, satellite imagery, we've been discussing this at the World Bank for some time, and there's obviously a range of types of imagery that we're talking about, ranging from completely open source data, which you can get from sources like open source OSM or others, which can provide you some insights. And those are also going to be useful at some stage of our client dialogue or project preparation at a very preliminary stage of project identification. Then you get into kind of different stages of the project preparation process. And at that point, it becomes a question of to what extent the satellite imagery can actually answer the questions that you want to answer, and at what cost. So when we're, the types of imagery we've been leveraging in several countries now is the low resolution free satellite imagery, which allows us to understand what kind of a road it is. Combining with AI, we can understand what kind of, if it's a paved or unpaved road. And it can allow us to detect an overall condition on a qualitative scale. And that is going to be perfectly fine for the kind of preliminary stage of project preparation, where we are just trying to understand, have a comprehensive sense of the condition of the entire network. And sometimes we're talking about 1 million kilometers of roads in our largest client countries. And that is going to be kind of fit the need of that. But when we're talking about the later stages of project preparation, where we have already selected, let's say, a few hundred kilometers of roads that are actually going to be improved with a World Bank loan, that's where it becomes kind of a, the question is whether going the high resolution satellite imagery route, which will cost money to buy the data, whether that makes sense or whether we should rely on more traditional methods. And I think that we have kind of concluded that it's really the early project preparation stage, identification and dialogue stage, where the free satellite imagery has really helped us, and it has saved a lot of resources and time. But when we get into the later stages of projects, we tend to kind of revert to obviously more traditional methods. I'll just mention a couple of examples of how we have used this low resolution satellite imagery, which comes for free from the Copernicus satellite, combining with AI, and then just mention some other examples of other data. So the first example is from Peru, which is it's famous for kind of a very long-standing rural roads investment programming. It has improved hundreds of kilometers of rural roads in the past, with studies showing important effects on poverty reduction, on agricultural incomes, etc. And so in the past few years, we've been discussing with the Peruvian government what could the next ambitious rural roads investment program look like. And basically, rural, to give you a sense, Peru is very exposed to climate risks. It has very varied geography, and the government does not have a systematic asset management system that really kind of captures all these roads. And so they have pre-prioritized, I think, about 20,000 kilometers of roads, but that's not something that we can include in a real investment project. We should be narrowing it down to, at most 1,000 kilometers. And so that is kind of the perfect use case for applying low resolution satellite imagery, because it allows us to, for very little money compared to traditional methods. I think we estimated it to be about 6 times cheaper to do this assessment using satellite imagery and AI as compared to traditional methods. It allows us to have this very comprehensive understanding of the condition of the entire network. It allows us also, by bringing in, combining several different open source data sets like OSM, Facebook, Meta, Bing, I think there was another one, Microsoft, I can't remember, but basically bringing in all the different open source data that's out there. First, we were able to just map the entire network that is out there. And we found that there were many roads that the government was not aware of, especially in the rural areas of Peru. And those are the roads that are most likely to be vulnerable to climate change, most likely to be unpaved, and most likely to also be actually very important for rural residents to access the main corridors. The other example that I'll mention is in Mexico, where we do not have an actual investment lending program in the road sector, but the government is looking for advice on more sort of technical and policy aspects. One is road assets recycling strategy. Basically, how could it leverage its existing road assets to generate new revenues that can finance investments in urban transport systems, etc. And then they also really want to understand what is the road safety performance of these road assets. There's really not systematic geolocated crash data in Mexico, so they were looking for kind of innovative ways that we could capture what is the condition of these assets that they're managing, and also what is their road safety performance. And so again, we decided that leveraging the low resolution satellite imagery and machine learning methods would allow us to have this comprehensive assessment of the entire road network of Mexico. Here, I'm just showing the main roads in the picture. But that's something that even the government of Mexico did not have. It has the condition data assessed for the major roads, but we aim to also assess the ones that are not in that system. And as a second step, using that condition assessment that was conducted using satellite imagery, we combined it with street view imagery and automatic kind of object detection algorithms in AI to be able to detect what are the characteristics of these major highways that might pose a road safety risk. And we're using here a methodology from the EU. I think it was published in 2022 or 2023. It's an EU handbook on basically using sort of like a proactive way of assessing road safety risks using satellite imagery and big data methods, basically. And so this we decided that this would be the perfect method to apply to the concession highway network of Mexico to really understand what are the risks of that network from the road safety perspective. And this is not just important because of the objective of saving lives and improving road safety, but also because the government aims to leverage this in sustainable investors like ESG investors to actually invest in this network, and indicators like road safety become important in being able to attract those kinds of investors. And then another example here, the final one in this area, is the one from Argentina, where we've been working with the National Roads Directorate, the DNV, on kind of expanding the work that we did in Mexico and Peru and try to adapt it to the needs of Argentina. The specific angle that the reason why we are engaging on this topic in the first place is because we're focusing on the northern regions of Argentina, which are a little bit poorer than the rest of the country, but have a lot of agricultural and mining potential. And so the idea was to really understand what is the condition of the road assets that are serving those value chains in the mining and agricultural sectors in northern Argentina, and then work with the National Roads Directorate to see what other kind of customizations of the method could be useful for them. And I will say, like, this was a very interesting learning experience for I mean, the World Bank here was really acting as an intermediary between the Roads Directorate and the firm that was performing this work. And I think that we learned that basically there are definitely limitations to which to how much this method, the leveraging of satellite imagery, free satellite imagery, to what extent it can be useful for different countries. And so, for example, we learned that in Argentina's case, it was really the provincial road network where this kind of approach was most valuable, because there's very little data available on the provincial road condition, whereas the national network is already sort of well managed and has a lot of information about it. And so it really was in the process of working with the DNV that we found what is the right focus area for this methodology. And then as part of working on this condition assessment, we also, basically came to other applications that the DNV could benefit from, in terms of leveraging climate risk data overlaid on top of the network. So, for example, we learned that 16% of the unpaved provincial network is at risk of flooding, and so this is, especially for the unpaved roads, I think that was the conclusion, that it's not so much the assessment of the condition, which might be varying over the season due to rainfall or due to other reasons. It's really the vulnerability of the unpaved network that matters more, and that can inform maintenance strategies or decisions of whether or not the roads should be paved in the future. And then I'll just quickly mention these other applications. So one is the Rural Access Index, or any type of cross-country benchmarking or indicators, and as well as understanding what are the investment gaps at the country scale. So this is, again, sort of more from the corporate perspective. And I'll just mention here again how the work that we did in Peru, which allowed us to identify the paved and unpaved roads as well as their condition. We then use that assessment to be able to basically map how many, what is the Rural Access Index of Peru? Basically, how many people in rural areas of Peru are living within 2 kilometers of an all-season road. And of course, to define what is all-season, those kinds of, the pavement and condition assessment was completely essential. And, the Rural Access Index is something that the World Bank has committed to measuring for every one of the client countries. It's something around like 180, 190 countries of the world. And to be able to do that for every country of the world, we really need to rely on kind of low-cost, innovative methods like satellite imagery and AI. It's impossible that we could assess the Rural Access Index using traditional methods for all of our client countries. And then the very last thing I will mention is the research applications of this kind of data or methods. So, of course, we don't improve roads just to improve roads. We improve roads to actually have an impact on the ground on things like food security, farm productivity, and education and health outcomes. And we need this kind of consistent data and on the road condition to be able to use it as a variable into regression models, basically. And so I'll just mention one example from West Africa, where I was based before coming to Latin America. So, for example, if we want to understand the link between road condition and human outcomes, like education or health outcomes, basically, the more efficient the transport infrastructure, the more that we could expect that children can attend school, people can get to clinics, pregnant women can have medical checkups. And so we really try to understand if that is the case in the case of West Africa, a specific country, Burkina Faso. And I'll just mention here that basically, again, this kind of to be able to understand these statistical connections between infrastructure condition and health and education outcomes, we used the road condition data at this country scale and combined it with indicators on things like school attendance, enrollment rates, completion rates. And we found that basically there was a strong statistical association between the Rural Access Index and children starting school, children completing school, and that these impacts were even stronger for girls than for boys. And we also found very strong statistical links between road condition and maternal mortality outcomes. And this is just to illustrate that this is another side of the World Bank. All of the things that have to do with knowledge generation and creating evidence on how infrastructure matters for development. Thank you. I'll stop here, and I apologize that I have to disconnect early.
Muchas gracias, Aiga. Muy interesante tu
Thank you so much,
presentación.
Aiga. That was a very interesting
Podemos
presentation.
compartirla con los
Can we
oyentes.
share your presentation with the participants? Sure.
No veo preguntas
I
concretas
don't
en
see any
el chat.
questions
Yo
in the
tenía
chat.
solo una
I
pregunta,
just have
que
one
es
question,
cómo
and that is,
definen para
how
cada
do you
camino rural que
define for
esté
each rural road
abierto todo el
whether
año, es decir, all
it's
season.
all
Yeah,
season
it's really
open?
just
I mean,
just a combination of combining whether it's paved or unpaved. So if it's an unpaved road, we look at what is the slope of the road, what is the rainfall exposure of the road, and it's a combination of the two. Basically, if it's an unpaved road exposed to a lot of rainfall, and if it's located on a slope, it basically allows us to predict an index of exposure. And the higher that index of exposure, the less likely it is that the road is all season. But I can share the specific analysis that was done for Argentina, I think. And Tomas from Altea, who is going to be presenting next, I'm sure that he will be also able to explain in more detail. I apologize, but I have to go now.
Muchas gracias por tu
Gracias.
participación. Muy
thank you
interesante.
for your participation. That was very interesting. Thank you.
Anticipó Aiga,
So, as I
continuamos con
anticipated, now we will continue
Tomás
with
Labús.
Thomas
Él
Labus.
es
He
Global
is
Sales Manager
the
en
Global
Altea.
Safety Manager at
Lleva
Altea,
trabajando en Altea
and he's been
algunos
working
años,
at Altea for a few
presentando
years
nuevas
now.
soluciones
He's going to
técnicas
present
a
new
grandes
technical
operadores de
solutions for
infraestructura.
large infrastructure
Anteriormente
operators.
trabajó en el
In the
sector
past,
público,
he
en el
worked in the
servicio
public
diplomático,
sector at the
como
diplomatic
delegado
service
económico y
as an
consejero
economic
del Ministerio
attaché
de
and
Economía
counselor at the
francés,
Ministry of
donde estaba
Economy
a
of
cargo del
France,
desarrollo.
where he was responsible for
Bueno,
infrastructure
bienvenido,
development.
Tomás, y
Welcome,
el
Thomas.
floor es tuyo, como
The
dice.
floor is yours.
Thank you very much. I will share my screen maybe, unless you have my
Puede
presentation.
compartir el...
No, you can share your screen, Thomas. Go
Okay.
ahead.
Okay,
Thank
I
you.
will then. Thank you very much. All right. Sorry for the little up time. It should be okay. We should be on now. Can you all see my screen?
Not yet.
Yet.
Still not? Okay. Now?
It's
Now.
coming.
Great.
Here we can see it. It's not the full screen mode, but oh, okay, perfect.
Perfect. There. Okay, thank you very much. So yes, I'm Thomas Laibuz. I worked at Altea as a sales director for the Middle East originally, and I switched recently to the public sector of our company. I recently started working with AIGA and the World Bank on this program that we help support. Basically, AIGA presented the entirety of the program, so I will just walk you at a very high level, and I will keep it short and simple because I'm not a technical guy myself. On the methodology that we used to end up to where AIGA presented you the use cases. So again, the core idea behind the program was to leverage the best private practices to help better the public policies. And for that, we wanted to use free or almost free data, which meant basically using low resolution satellite data. And the road networks is what is the easiest thing to see with this kind of data. So that's why we also ended up choosing this kind of infrastructure for the program. So basically what we do is we take optical data, which is the classic photograph from satellites that you see here on the left. SAR data, SAR is the radar data, and we aggregate that with any kind of visual open source data that is available to create the most complete digital twin that is possible. And on those, we can run different kind of analysis that allows us to have a quite accurate understanding of the state of our infrastructure. So to do all that, to arrive to this digital twin, we have a 3 steps process. The first one is to create a vectorization of the road. So for that, we use the famous open data that we talked about. It can be a lot of things, but mainly it is OpenStreetMaps, Bing Maps from Microsoft, and Meta data from Meta, Facebook. And what we do is we do a conflation of all those data. And every time there is a redundancies, we eliminate the redundancies. And we keep all the extra segments so that we can arrive to the most complete digitized network. So that has been proven to be 60% more complete than anything you can find online directly. And yeah, and so once you have done that, you have the most complete digitized network available. Once you have that, we download all the satellite tiles that are in which your vectorized route appears. And with that, we developed a deep learning and machine learning methodology to analyze the value of every pixel in your satellite tile to see the reflectance of the pixel, which allows us to determine if this pixel is a paved or unpaved segment of the road. So that's it. So this first step allows us to create this indexed or paved or unpaved that Eiga was talking about. After that, we do the exact same thing, but with SAR data, so the radar. So again, we take all our satellite tiles with this time radar, and we used AI to define a methodology that allows us to use this kind of data, because what's very difficult with this is that radar data is not gonna be the same according to where your satellite was at a different time of the day or a different season, or if there was clouds or the weather was different. So we developed quite a lot of algorithm to be able to create a base of comparison to work on this. And once we could use all that, once everything is calibrated, we use this to analyze the value of roughness of the roads, and that's analyzed through what we call noise. So if you have noise on your radar, it means that it's very rough. If it's flat and no noise, then it's a smooth road, so it's a good, it's really nicely paved. So that allows us to create our second index, which is the roughness index, and it allows us to create a classification of the road. Namely, we have a good segment, medium segment, and poor segment. So that's how you end up here. You have your three entries, so vectorization, optical, and radar. And so that we can extract some characteristic and create this tree decision making decision tree. I don't know how you say that in English, to be able to make a prediction on your on the state of your asset. So that's really the basic approach on how to create a digital twin, on which we can then further push the analysis and do all that Eiga mentioned. So you can have the all season road analysis. You can have the TWI, which is the topographic wetness index, to kind of analyze the the propension of segments for water accumulation. Really a lot and lot of things. So here you have an example of how it looks at this very first level. So you have your network that is calibrated on with GIS data on the satellite image with the segments paved and paved. And what's interesting is that it's really cheap and quite fast to do. Basically, to do an entire country, we talk about 50 to maximum 100,000 euros. That can be done in less than a couple of weeks. So that was our approach to support the World Bank in its program. That's where I stop today because that's what I have. Sorry, I prepared for today. But as you will see on EIGA presentation, we can do a lot more things coming from there. That's it. So I'll take care.
Oh, de acuerdo, muchas gracias por la presentación.
All
Esperemos
right,
que
thank you very much
sigan
for that
avanzando en el
presentation.
análisis
Hopefully, you will continue to move forward with the analysis of road infrastructure. I know that you're working in Argentina, so we are eagerly looking forward to some additional
Si
results.
no hay otras preguntas,
If there are no
Daniel,
further
daré
questions,
el piso
I will now give the
a
floor
Afonso
to
para presentar
Afonso so that
el
he introduces the following speakers.
Okay, thank you. I'll start off by presenting Jean Ramirez. Jean Ramirez, he has two prominent roles. He is an elected representative for FFB. This is the French Federation of Bâtiment, one of FIEC's members. He is an elected representative for the department Rhône Ardèche, which is in the southern France. And he has also been since 2018 a member of the National Working Group for Artificial Intelligence. On top of that, he is also an entrepreneur who leads companies in various sectors, such as plumbing, heating, construction, and these companies include Largier Technologie and Electro Industrie. His group, which is the group Islode, it has five agencies in different departments in France. It employs 200 people and had a consolidated turnover of 23 million, and it focuses on areas such as public works, industrial projects, and so on. And his presentation is already on the screen, so he will first give us an overview of the work of FFB, and then he will go talk about the projects in his company. So I give him the floor.
Gracias. ¿Se ve mi?
Thank you.
¿Se ve
Can
mi,
you see?
mi pantalla?
Can you see my screen?
Sí, bueno, muy bien. Pues
Yes.
empiezo.
Thank you so much. It is a pleasure for me to be here. My presentation will be divided into two. On the first part, we will be talking about what we do in our French Federation, the FFB, and then I'll try to explain to you what we do in our companies. In terms of the applications, my applications are a lot more modest than what we've seen so far, but I'll do my best. Let me show you what we're doing with the Artificial Intelligence Working Group at the heart of the FFB, the French Construction Federation. This group was created in 2018 with the publication of a road report that was requested by President Macron. We were really surprised when we saw that the construction sector was completely absent and missing from that document. Considering this exclusion, we quickly created a working group to explore the AI opportunities in our industry. So we've been collaborating with academics, experts, and many other partners in order to develop a roadmap that included our sector. We have achieved many things in our group. We have elaborated 3 reports that you can see here. We've published a special edition of the Constructif magazine, which is very important here in France. We have developed 2 tools and many different videos, podcasts, and web seminars adapted for different companies in order to facilitate their digital transformation. Another important goal of this group is to create local adaptations. For example, in my region, in the southern part of France, we have created a local group that gathers 20 to 30 companies every month to share good practices and learnings about AI.
Los desafíos y las oportunidades de la inteligencia artificial en
What
la
are the
construcción.
challenges and the opportunities for AI in construction? Well, we want to be active players, we want to be pragmatic, we want to make the most of this technology to be active players on innovative topics to protect the interest of our companies, considering, of course, a responsible use of personal information. We want to make AI a market of opportunities and contribute to the provision of new services to improve productivity and create value. We want to strengthen our jobs and to make them more attractive for young people. We want to reflect on geopolitical issues and challenges. We want to support the European third way vis-a-vis the China and the United States in terms of AI. If we look at our colleagues in our companies, we wonder, where should we begin? We should first convince business leaders to be a part of this transformation. We need to analyze data. We need to map the data available because that is the true fuel of AI in order to visualize different data flows. We want to understand the relationship between the different data sources. We want to analyze the gaps and the redundancies. We want to as well conduct an inventory, working with our databases, the files, the external systems, the web services, and so on. We can be talking about digital files or physical paper files. We want to as well to reflect on the data governance, who are the data owners, the users, the frequency of updates, and so on.
Eso era un enfoque sobre
That was the initial part in terms of what we do with the FFB. Now let me tell you about the projects that we work on in our companies. I will be focusing on my experience as an employer and an entrepreneur to tell you about the challenges that we've faced in our companies. Our group includes a company that is specialized in infrastructure development, and we weren't really competent on AI, so we wanted to make the most of the IA booster device. At the second stage of our program, I will tell you how we incorporated a data scientist on dual information to help us develop projects. Here you can see the IA Booster France 2030 device. This is a device that was implemented by the French government that has 4 stages: a stage of awareness, analysis of data, the definition of a use case, and a 4th stage would be the specific development of proof of concept. We are now working on the 3rd phase, and we're moving on to the 4th phase. From the beginning of this program, we leveraged and we made the most of an 80% of subsidies, which made it possible for us to speed up our work on AI. So, how did we begin? We began with 2 key actions. As you can see here, the map of our data, the mapping of our data. This is what allowed us to identify the data available in our system, to identify gaps and redundancies, and to understand the relationships between the different parts. Then, we've prioritized here, as you can see, we have prioritized our use cases into 2 criteria on the, oops, this is the wrong slide. This is the correct one. As I said, we've prioritized our use cases. To the right, in the x-axis, you can see the costs, and in the y, the vertical axis, the benefits of this. We can see about 20 identified use cases here. What we've done was to look the low cost and high impact cases. You know, the little stars that you can see on the graph are the cases that we chose. So, let me specifically show you 3 cases that we've applied from our company. The first one would be the automatic completion of the fiche d'intervention, the intervention card. Here we can work with maintenance tasks, and material data sheets for the technical people. The technicians speak out loud, and the device formats that information and translates it into text. This helps us reduce the administrative load, and we can focus on our job. That's what the technicians do. In this use case number 2, here we have the dynamic management of emails in this application. Although you can see the budgeting software behind in the background, and then this automatically integrates key indicators into budgets. You know, we're talking about features, availability of stock and materials, and so on. And then we have the accompanying letters that are created automatically based on the quotes. So we have cost savings, time savings, and we improve the communication with clients. And a 3rd case that we have operating in our company is the optimization of technical queries. We have implemented a system called RAG, R-A-G, that avoids errors caused by linguistic models that create seemingly truthful responses, but that are not precise. So these responses are based particularly in our technical parts that we saw before. It's sort of our internal Wikipedia. And this ensures that the information that we provide is reliable, and we can avoid mistakes made from external sources, and we can speed up the search times and the summary of documents. To those 3 specific cases. We have continued to work on them with our data scientist.
Se ve en la izquierda del documento.
And to your left, you can see the set of documents that are part of the digitization file or dossier and the tender dossier that is very important in France. And to the right, you can see the quotes that we saw before. And the goal here is to automate the transformation of tenders directly using our management system. The goal is to considerably reduce the time it takes to transcribe the tender information. And for example, in my company, the cost of the time that it takes to prepare a budget is of about 200,000 euros. In terms of the expected return would be to increase an opportunity in 15 to 20% so that our teams can focus on more value-added tasks. To wrap up, I think that these applications show that artificial intelligence can be used in our sector, particularly in smaller companies like us, construction companies that are small, to reduce administrative costs and optimize processes. Thank you for your attention.
Okay, thank you, Jean Ramirez, for the overview of the activities of FFB and also for the overview of the use cases in your companies. Giga has posted a question in the chat, which I will read, which is what technology is behind the quote generator, and is it LLM based or other technologies?
Alguien para ayudarme para traducirlo.
Can somebody help me into French? Right, it says, what technology is behind the quote generation? Is it LLM based or other technologies? Well, the quote software is our own. We've engineered it. The text generation is done via LLM. We use Mistral, which is sort of the equivalent to ChatGPT in France. I think that there's a question behind that question, and that is, we don't send any critical information like our prices. We don't outsource that. We don't send it outside of our company. We just use this for it to prepare, the letters that go with the documents, the supporting documents that go with the quotes. That's why in our final case of use, we want to include in our infrastructure the in-house models, right? So that we don't send any kind of crucial information of our company outside. Let me ask a question as well, Jean, sorry. In the Inter-American Federation, I'd say that 90% of the companies represented are small and medium-sized companies. So I'd say that they are starting to think about working with AI or have barely started with this innovation. Could we have access to the videos of the FFB that you mentioned in some of your first slides? Could we possibly have access to them? Because I think that as an onboarding or an induction process, I mean, of course, we would have to translate that, but that wouldn't be a major obstacle. Sure, yes, that would be a good idea. Because we've done a lot, right, to understand what AI is. Sometimes we can get confused between AI, IT, and in that information, in that material, we can provide the limits of what AI can do. Well, in fact, at the FIIC and in the Argentine chambers, we've been working on this. There are many players that are involved and that have been contributing, but, you know, getting to know the French development can be an interesting benchmarking for us. Well, 80% of the companies that are part of our group have less than 10 people working on them. So it's pretty much similar to what you just said. Well, yes, generally, I think that this is a global condition. The construction sector has a huge amount of SMEs and a few large companies that do other kinds of endeavors. Also, we have the government clients that are the ones organizing the country's infrastructure. There is another question here in the chat. Could it possibly be in Spanish? It says, may I have the reference of the cited workbook? Yes, we will share this with Andine, and she will share the information with you about these 4 books from the Federation. Afonso, you have the floor.
Thank you again. Now we will move on to our next speaker. I won't pronounce the last name because I'm having difficulties with it. So it's Mateja, then you will complete it. Mateja has a PhD in engineering. She is a researcher from the University of Maribor in Slovenia, focusing on optimization and structural engineering. After she had completed her PhD, she went on to explore digital transformation in construction. Since 2023, she's been involved in a project combining optimization methods, BIM, and advanced technologies such as AI, Internet of Things, and digital twins to improve efficiency, safety, and also sustainability in construction. And on top of that, she holds a research position at GIC Granje, which is a leading construction company in Slovenia. And there she works on improving construction management, reducing costs, and promoting sustainable practices. So I give now the floor to Mateja to do her presentation. You have to turn your microphone on.
Okay, you can hear me now, I think.
Yes.
Okay, thank you, Afonso. Yes, I am Mateja. Don't mention about Držečnik, it's very difficult to pronounce for you, so Mateja is just fine. So today I will talk about the role of AI in smart concrete plant in our company, GIC Gradnje. So let me start with the presentation. Okay, first I will say a few words about the company and then explain the main reasons, implementation, and key benefits of AI in smart concrete plant. So GIC Gradnje is one of Slovenia's leading construction companies, has a long-standing tradition and over 1,000 completed projects. In recent years, the company has focused on digital transformation, implementing advanced technologies, and improving workflows. With a team of 250 employees who are a cornerstone of the company's vision, GIC Gradnje strives for sustainable future in construction while reducing its carbon footprint and using resource efficiently. The company operates on 3 core principles. First is innovation. by introducing new technology as digital twin, the Internet of Things, artificial intelligence, and of course, extended reality, the company transformed traditional practices to the modern digitized processes. Second one is sustainability. GIZ Gradnia, GIZ Gradnia is committed to the green transition and promoting sustainable practices, including waste reduction, energy efficiency, and enhanced workplace health and safety. Third part is employee-centric approach. The company embraced the Industry 5.0 concept, emphasizing employee safety, continuous education, and transport to the digital transformation. Here we see the digital transformation of GIZ Gradnia. The main reasons by the following is addressing labor shortages. This is technological advanced workplaces attracted to young professionals and enable increased process automation. Digital twin enhanced collaboration between humans and machines, ensure greater precision and reduce human error. Real-time data monitoring. Real-time data monitoring is ensure faster and more accurate decision while optimizing production processes. Process optimization and efficient resource are contributed to the reducing the environmental footprint. Consolidating all documentation in one place improves transparency and facilitate easier processes to management. You can see here the implementation phase of digitization at GIZ Gradnia, focusing on the Argo XR technology. The phase is divided into 4 key components. First is cloud. This is a centralized knowledge base, consolidate essential information, enabling easy access and sharing among stakeholders. Integration with sensor systems facilities seamless data collection and monitoring. A step-by-step instruction editor simplifies the creation and dissemination of detailed operation guidelines. Here you see the training, the use of immersive virtual work environment allows employees to engaging with realistic simulation. Simulation of infrastructure and processes provides hands-on learning experience. Collaboration sessions among users encourage teamwork and problem solving in virtual settings. Here you have guidance. This is virtualization of work processes, enables visualization of tasks, enhancing understanding and execution. Step-by-step multimedia instruction provide clear guidance for complex processes. Indoor XR navigation supports precise navigation and task execution in virtual environments. And of course, remote assistance via digital twin allows for real-time support and troubleshooting without physical presence, leveraging the capabilities of virtual model. This whole framework ensures smooth implementation, robust employee training, and effective operational guidance in all underpinned by innovative technology. Here are describe key benefits for our company. The key benefits of digital transformation at GIZ Gradnia can be summarized into 3 significant areas. You can see here, first, enhancing transparency and traceability. By adopting this advanced technology, GIZ Gradnia has revolutionized its ability to monitor and track processes. This technology enables seamless integration of digital tools, devices, and systems, creating an undefined platform where all documentation is centrally stored and easily accessible. This integration not only improves operational clarity, but also ensure efficiency, coordination across different workflows. Process optimization, the company has prioritized, sorry, I'm too fast. The company has prioritized sustainable and efficiency through its operations. During the design phase, emphasis is placed on minimizing environmental impact. From design to construction, GIZ implements measures to reduce waste, uphold workplace health and safety, and follow the highest standards of the best practices. Positive changes that we categorize is digitization has led to tangible improvements in both user experience and operational performance. Systems are more user-friendly with improved clarity on how processes function and greater reliability in workflows. Resource efficiency has been significantly enhanced by reducing waste, raw material consumption, and energy use. Time efficiency has also improved with faster transition from project conceptualization to implementation, allowing the company to respond more rapidly to the market demands. And through this advancement, GIZ has not only modernized its operational, but it strengthened its commitment to sustainability and innovation, setting a benchmark for the construction industry. To conclude, we have prepared a short video about our smart concrete plan to give you a better understanding of its operational and the benefits the digitization in practice. So I will just play. Okay, and you can see this is very important for the maintenance also. Of course, this is the main part. And the last part is one sentence that I saw this on LinkedIn today. No matter how advanced AI becomes, it will always need a human touch. So thank you very much.
Thank you, Mateja, for your presentation. I don't know if anybody else had a bit of trouble seeing the video. It may have just been my connection, but if you can share the link to the video, maybe in the chat, that would be a good idea. I don't see any questions in the chat, but since
Me gustaría hacer una consulta.
Yes, I would like to ask a question, Afonso. Do you have a digital twin of the concrete plant? Is it operational?
Yes, we have.
Pueden operarlo a distancia.
Can you operate it remotely then?
Yes, we can operate remotely.
A pesar de las diferencias.
Despite the differences in the aggregates that can vary very rapidly?
Yes, we have all components visualized to the operation system. So if something is not good enough, we have one team that is capable to ensure it's better vision. So we have this team. This is outsourced team. This is not civil engineers, but they are other team, and we have all this complete.
Gracias.
Thank you.
Yes, and since you mentioned trainings in your presentation, can you just elaborate a bit more on how the employees were trained to use this new system, and if the process was smooth, or if there was any challenges that you encountered that are worth?
Yes. Okay. Employee were trained using this Argo XR platform, which provides step-by-step multimedia instruction. But we have some difficulties to provide this because the young generation don't mention, and it's very quite interesting about this. But we have the older employees that they must this is a very new technology, and they didn't know how to provide this knowledge, what it is, how to provide the tablet or the VR glasses. But now when they know everything, is no problems from them.
Thank you for your comprehensive answer. I don't see any other questions in the chat, so now I give the floor to Fernando for the next presentation.
Muchas gracias. Bueno, es el momento ahora
Thank
de
you.
escuchar a Blanca
Now
Payas,
we are going to listen to Blanca Payas. She has a degree in geography, a master's degree in satellite teledetection, more than 20 years of experience in Earth observation by satellite applied to civil engineering, natural disasters, and risk reduction, oil and gas, and mining. She has developed her career in several companies in the space sector and in the instrument monitoring section. Most of her work has been related to satellite monitoring of large infrastructure projects globally. Currently, she is the director of Sixth Sense, a company of the Vinci Group based in Barcelona, Spain, and there they provide services to projects worldwide. So she's going to talk about INSAR, that is one of the most important satellite services used for infrastructure maintenance. Thank you, Blanca, so much for your participation. The floor is yours.
Thank you very much. Good afternoon. I would like to confirm that you're looking at my screen. Yes, great. First of all, I would like to say hello to Fernando, Alfonso, and everyone else for inviting me. I'm deeply thankful, and let me try to make an agreeable presentation. I know that interferometry can sound like something that is too technical. I will try to be amenable. We're going to be talking about a teledetection technology from satellites that is extremely operational in the world of civil engineering and infrastructures, construction, mining, and that due to the advances in the past decade, where we've launched to orbit so many satellites with increased features in terms of resolution, precision, and data quality and quantity, well, we have AI and machine learning techniques that would used to be science fiction to us and have now become a traditional element and tool for us in these services. Let me give you a brief technical overview, and then we'll move forward with some examples. I think that that is the most clear way to explain this. What is interferometry? If you don't know about this, this is a teledetection technique that is based in the use of satellites that have a very particular sensor on board, a radar, an interferometric synthetic aperture radar. This is an active sensor, that is, it sends pulses and collects the how it rebounds, and then it takes images. Our satellites will orbit the polar orbit, so they're going from the North Pole to the South Pole while the Earth rotates. This makes it possible for us to see all of the Earth at all times, and it makes it possible for us to revisit the same position days later. Our radar takes an image that is emits a pulse on a city, Lima, for example, and we say, take an image. It issues or emits the pulse, and it picks up the rebounding pulse, and then we go back to it in a couple of days. If due to seismic reasons or construction reasons or a TVM or other, dewatering reasons, we may need to check whether a building has moved. Then once we see the second image, it'll happen the same, the same movement, but the rebound will be lower. This is the phase of the radar image. So interferometry is based on quantifying, measuring these phases differences. We take many images of the same place in different points in time. We input them in our software, in our processing chain, and the output, that is what we give our clients, are movement maps in terms of the terrain or the surface infrastructures with millimetric precision from satellites that are orbiting 700 kilometers away from the Earth. This is an example of an interferometric result or INSAR. You can see green, and that the convention says it's a stable, and then the red is settlement, and the blue is elevation. This is this is a map of London, and we see the the tunneling machine. You can see here as it moves through the city and creates a settlement, this mild settlement, and we can measure this. We're talking about 2 to 3 centimeters here in terms of elevations. Each one of these colored dots that you can see on the screen is a pixel that has an expression in the field. It can be 1 meter by a meter, 3 meters by 3 meters. It depends on the satellite. So when in our GIS we click on our pixel, then we will see a time series that shows the evolution of this specific piece of land, soil, bridge, building, and how it has evolved in time. We see the millimeters and here the years. Every time the satellite goes through that place, it takes an image and we can add a point in our time series. This is how the interferometry works. So what we do here is to schedule a satellite to take images of a specific place. We have a project in Sao Paulo, in Mexico City, so we call the agencies and we tell them, well, please, every week, take an image of this location. The spatial agencies keep on land a network of ground stations. That's where the images that we've requested are downloaded, and from there we have access to them and we put that in our own computers. From our computers, we are located in Barcelona. We have a group of experts here. They put the images into the computer and we begin the processing where we calculate the faces and the results that we can deliver in different formats. We can see these ground motion maps. Let's talk about the users. Which are the sectors that are using this technology in the infrastructure, civil engineering world, construction world? Well, anyone that's interested into seeing how the ground moves or how their infrastructure works and how that can have an impact on the life of people. We'll go deeper into maintenance and AI later in the presentations. We do a lot of tunneling projects. We work with cities. This is Guadalajara, for example, in Mexico. We work with municipalities as a whole. We work a lot with linear infrastructures. We're talking about roads, railways, ducts. We do radar satellite images, and these are large images. We're talking 50 kilometers by 50 kilometers, 100 kilometers by 100 kilometers. So we can quickly and in a very efficient way have the scope of many areas. We work with mining a lot. We're thinking about Latin America. We work in Chile, Peru, Brazil, Mexico, both open pit mining and underground mining. And of course, we work with tailings dams. Their criticality levels and their need for constant monitoring is something that we also do. We also work with dams and canals. We work with the whole water world. The infrastructures are extremely important nowadays because it helps us preserve water. And we also work a lot in during natural catastrophes or natural disasters. The climate change is not so natural, but we work in this interaction with infrastructure. That is, we are able to understand how things are happening and the impact that it can have. So this is a clearer slide because we want to look at our needs, clients, and benefits. We work with different engineering offices, with construction companies, and lastly, we also work with the asset owners of the infrastructures and the concessionaires from government departments. When do they reach out to us? This is important. Interferometry is the only technology to date that can allow us to look back, look into the past. The radar satellites have been orbiting since the year 2000, so we have between 20 and 30 years data from satellites that have been orbiting since then. So these satellites have been acquiring images from the Earth that have been stored in libraries. Interferometry is the only technology that allows us to look into the past. And during the infrastructure design processes, engineering people call us because they want to understand how the ground behaved before their own design and include this behavior in their planning and design stages. The construction companies and the asset owners call us because they want to know how a certain plot of land, a certain infrastructure was before starting a construction work, because we will have a map of how this behaved, and this is a great tool to protect from claims and from any kind of legal case. So, using INSAR in the design phase of an infrastructure is something that is happening for everyone. So then we move on to the construction phase. We've finished the design phase, and in the construction phase, generally the engineer people are not talking to us anymore, but the construction companies and the asset owners really rely on us because, of course, construction companies nowadays already have in their own tender processes, in their planning manuals for instruments and monitoring, mandate using INSAR throughout the world. So they call us to include this information into their monitoring plans because they can have a bird's eye view and see beyond the area of influence or the zone of influence, because we know that that sometimes becomes larger. And as for asset owners, well, it helps them have a supplementary and independent tool to monitor their own construction companies. Lastly, once the construction phase is over and we move on to the operation or maintenance phase, the instruments have been removed and we are all left with the satellites. I will show you some purely maintenance projects, and interferometry is a tool that provides you with data without going on site from large areas with high precision and detailed information. So we can do hotspot inventories. We can also analyze vulnerability. We can plan for preventive maintenance and to reduce risks as well. Let's move on to the practical side of the presentation so I can show you how we implement these advanced techniques thanks to the large amount of data that we have, where you will see machine learning and AI techniques are playing a supporting role so that we can implement the information and focus on the more complicated areas. I've prepared 3 case studies, 3 different projects. These are all real projects. We always work at the operational stage. We work with the industry that needs us. And this case is a road, a highway road. The client is a concessionaire at the north of Greece. This is a highly unstable geological area. This is a road that takes us from the El Pireo to Patras, and then it goes 300 kilometers. It's a 300 kilometers road. The concessionaire just calls us, says, we've just acquired 300 kilometers of road and we want to understand its vulnerabilities. So we started by doing a historical study. We acquired the images from the previous 3 years. We analyzed those images and we were able to do this that you see here. It's a map with different points. We were saying whether it was stable, whether there were movements, critical or non-critical, that is redder or less red. And then we were able to see that there were areas of the road that were at risk. So a solution was provided by us. We had to manage the different reliefs and levels. We used machine learning and AI algorithms to prepare all of the different areas and to see how the movements behaved. In this case, these data we're talking about 500,000 measurement points throughout 250 kilometers. Well, actually 300 kilometers. We took images every 12 days. We process them every 6 months, and we deliver results every 6 months to the client, except for when there was an earthquake. So we did an emergency measurement. We measured to see whether there were ground movements that had accelerated or shifted in terms of trends due to that earthquake. And actually there were these kind of movements. This road is an area with many faults, geographical faults with steep relief. This is a different project. It's a project in a municipality. The government is our client. This is in New Zealand, the Auckland municipality. The client concern was that this is an area with expansive clays. This is an area that is damaging the foundations of roads and buildings. So they told us, we need to understand how buildings move. We need to understand the seasonal movement pattern of expansive clays during winter and summer. This is breaking our foundations. On top of this, this is a cyclone area with tremendous storms, seasonal storms. So we would also like to have a detection of landslide or movements that are triggered after these extreme weather events. So the objectives were to build and create an inventory of buildings at risk due to these expansive clay movements and an inventory of landslides as well. We then involved different satellites at different orbits, and we started preparing our solution. We contacted Oakland geologists and geotechnicians, and we talked about how these expansive clays behaved in the southern hemisphere. So we looked for a pattern in terms of seasonal movement. That is a pattern that coincides from what we have processed. We processed a huge area in Oakland, and we got 10 million points of movement measurements. We had found 300 motion patterns and categories with the different movements, ascending, descending. But what we did was prepare an algorithm that would look for the movement that coincides the movements of expansive clays. So what we delivered to our client is as follows. We have an advanced GIS to be compatible with these points, and we delivered a map with a layer of the moving buildings so that we could show them the vulnerability of their own buildings. Then we also delivered a heat map where you can see the areas where there are points that have seasonal movements accumulated. This is a time series, a seasonal series. It's a minimum movement, 5 millimeters, but you can see them here. These are the areas where there are more expansive activities on the ground. And then we took the same map and developed a legend with different vulnerable buildings that are vulnerable to seasonal movements. The darker the building, the wider the seasonal movement. That is, the higher the risk of cracks and fissures in that building. While we were doing all of this, we prepared a heat map in which we included a digital environmental model, a DEM, that was provided by the municipality. We put that into our platform, and on top of that, we ran several algorithms to detect active deformation areas, that is 3 images after a cyclone. The cyclone comes on the day 1 of the month, then we took 3 images 5 days later, 5 days later, and after 15 days, we were able to analyze these ADAs, and we saw the areas in which the ground is moving more or faster or in a different trend than before. That is an activation, a vulnerability indication. That's where we send our maintenance teams. That's where we decide what has to be done, whether we need to articulate with other parties or not, whether some remediation measures need to be taken. During this study, this is a viaduct, and you can see how the satellite shows a linear settlement of a viaduct with the different details, the red area, the green area. There's a pillar that is moving here. So you can see the quality of the high resolution interferometry to date. And we can see from January 2020 to January 2023, we see how this viaduct moved 4.5 centimeters. This is a final project. This is a project for tunneling data. How can we protect our infrastructures during tunneling projects? In this case, this is a map of London. We've been working in London for so many years. We take weekly images in that city, and we use them for different constructive projects. So the goal and the objectives was to carry out an inventory of buildings or assets like bridges, viaducts at risk. We wanted as well to protect from claims and supervision of different third parties. Sometimes we're working with different construction companies throughout the city, and then they start pointing fingers at each other, and with the help of these satellites, we can define who's guilt who's the guilty party, and then we wanted to provide strategic information for an efficient instrumentation plan. The satellite provides precise and vast information, but it does not provide real-time information. It can never replace the theodolite that provides data every 30 minutes, but it can tell you where you need to place that theodolite. So that will save time and money as well. It is a great decision-making tool. Let's move forward. And you can see that we use many high-resolution satellites to create this map. We had 7 million points in this, and we could not give that to our client, right? We need to assist our client, and that is why we start with our analytics tools. This work that we did in London had 3 simultaneous tunneling projects, the London Power Tunnels, the Crossrail Tunnels, and the Northern Line Extension Tunnels. So we process the alignment and we do the buffering, particularly if they are doing water extraction activities, because if they do that, the settlement basins are expanding quite a lot. As for the active deformation areas, we pinpoint them and we incorporated them into the map, and we provide that to our client. These ADAs are areas that are showing movements that are similar in different areas at the same time. This helps focus on the critical areas so that you're not all over the place, and rather you know exactly where movements are taking place and when and where. Here we were able to surveil the tunnels and the buildings, and we took the map. We did an inventory of the buildings that were affected due to normal or differential settlements. And this is always a dynamic map, right? We get new data every week, so we can make it a dynamic map.
Notas sobre los beneficios.
I just wanted to give you some closing remarks on the benefits and thoughts on this technology. This is a technology that can measure in the past, which is extremely important because it gives us information before we begin working. It is a great tool for validation and inspection and to carry out inventory of infrastructures at risk. It is a great tool. I mean, if you follow the presentation, you can see that it has a lot of communication. It's a very visual tool. It is also a key tool in cases of litigation because you want to be protected. And if you have arbitration situations, this eye in the sky allows you to classify the risks and guilts. And I just wanted to convey as well that interferometry is something that needs to be included in the monitoring plans. And as for the construction world, it has great benefits and lots of economic savings, which is essential. Of course, you need to talk to the an appropriate, serious interferometry tool so that they can design the plan for you and they can explain and you can explain to them the needs for your own project so that the correct decisions may be made and the results can be appropriate. That's all from me. Thank you so much.
Thank you. That was very clear and very interesting. You're a very good teacher. And you have a question here. Can you read the chat or should I read it? Okay.
Mira, for a SHICUL, the highest resolution is in pixel 1 by 1 meter. So that's the pixel ground cell that we can measure. And precision on the readings is from 1 to 3 millimeters on the movement. Which satellite data we are using? We are using mid-resolution Sentinel from the European Space Agency, L-band long resolution from JAXA, the Japanese Space Agency, o SAOCOM, los argentinos que tienen un satélite con banda L, and then for high resolution we are using the Airbus Constellation, which is TerraSAR-X and PATH, or the Aegeus, the Italian constellation, which is Cosmos Skymet? Creo que contesté.
I think I have answered the question. Yeah, you did. You did. With lots of details. Is there any other question?
Afonso quiere cerrar entonces.
Afonso, would you like to close the meeting then?
We can close if there is no further questions from the audience. So once again, to thank the speakers for their participation today and the participants that posted questions. Just to a question to Ondine, if we are expecting then to receive the presentations afterwards to share within our networks, that would be very useful.
Yeah, we will also share the link of the replay on our social media and on YouTube especially.
Okay, that's very good. That's very good. Also, to the FIEC and as well CICA participants and FIIC, we next week FIEC will host its working group meeting on construction 4.0, where we will explore this topic a bit further. We will have some presentations from Slovenia again, but also Israel on the use of AI tools or in the construction sector in those countries. We haven't before opened these our working group meetings to an external audience, but since there was a collaboration with CICA and FIIC today, we will do it this time, and maybe that is also an opportunity to find some initiatives where we can take part together on artificial intelligence, possibly even as well. We had pointed out we could try to develop a roadmap on the implementation of artificial intelligence in the construction sector, so something focused at companies. So this could be also a good opportunity to have some more discussions on that. So for me, that is all. Fernando, I give you.
Muchas gracias a todos. Hemos tenido una
Thank you all.
audiencia
We've had a stable audience, around 80 connected all the time. I understand this has been very interesting, looking at the many possibilities that technology can contribute to our sector. So I would like to invite you to participate in the future activities. We will be inviting you to the activities we organize at the working group of CICA on infrastructure investment, and also for the other working groups as well. We have a webinar scheduled for January, and then we'll be sharing the details. But then if there are no further questions, I will pass the floor to Andine for her closing remarks. So thank you again to the speakers and to the audience as well. Thank you.
Thank you very much, everyone. And thank you, Fernando and Afonso, for moderating this session. And once again, thank you to all the speakers. So as I said, we will share the presentations and the replay in a few days. And meanwhile, you are more than welcome to join our working groups. And our next webinar at CICA level will be in January on AI and maintenance again. Well, thank you very much, everyone. And have a nice day or day for those in Latin America.
Good morning, good afternoon.
Hasta luego.
Bye bye, adiós. Gracias.
Recording stop.